Good morning, everyone, and welcome to the webinar on behalf of the EMMC and also on behalf of the OntoTrans project that is going to provide the webinar today about tackling materials and manufacturing innovation challenges with digitalized translation from conceptualization to ontology. We have the great opportunity to hear from about this topic from three speakers today with different views, different perspectives that all come together around this topic. So this will be Michael Noeske from Fraunhofer IFAM in Germany, Emanuele Ghedini from the University of Bologna, and Jesper Friis from SINTEF in Norway. So they are all participants and partners in the OntoTrans project and have been collaborating on this topic. So we will take these presentations and have some questions. If you have any, please add them to the Q&A. We can do some quick questions after each segment if there are any, and then continue with more of a discussion at the end. So please continue adding your questions to the Q&A. And then also, if there are more, if there's more opportunity, there's more need for discussion, we can also meet after the presentations formally finished in the lounge again at the table for more informal discussions. So with that, I'd like to invite then our speakers, and first speaker is Michael Noeske, and please go ahead, Michael.
Ladies and gentlemen, I'm happy to have been invited as a speaker for today's webinar. It seems that we today tackle a topic which appears to be digital, and we have come together personally online to perceive three perspectives represented by three speakers. And depending on your perspective, you may consider the performances today on the stage as a medley or as a supporting act and a headliner. You may set your accents as you like. So I would like to represent the perspective coming from manufacturing. The community I am from is adhesive bonding technology, and the Fraunhofer Institute, IFAM, has got in his title the manufacturing technology and advanced materials aspects. So I will try to assess the question, how can we accomplish innovation in manufacturing? After that, I will hand over to Emanuele. So concerning translation in manufacturing, our challenge may be to make innovation a white box and fair for us, meaning all of the citizens in Europe and possibly even globally. In manufacturing, following the international standard ISO 9000, innovation as a term relates to a new or changed object, realizing or redistributing value, and the activities resulting in innovation are generally managed by human beings. Translators support the innovation managers by performing translation, which is a dialogue-based semiotic process, and they translate a need into a solution. Where do the needs come from? Where are solutions required? The human need comes from an end user, is addressed to the manufacturer, who is representing or represented by an organization, and the thus expressed industry need is then kind of communicated to a R&D project manager within the organization, whose job then is to find a specific solution. That then later on will be an individual solution for the end user. In this process then, the translator will enter, and our idea is that translation shall be embraced in a holistic way. So if we start from a high-level innovation challenge, then this is global, and so is the high-level value to be realized. That means our approach is more general and quasi-global. We form ecosystems to gain speed, to join efforts, and to comprise further generations, possibly even generations to come. An individual innovation case and a new individual product is part of such a global scenario. The quality of products, which may be materials or services, is governed by the quality of information exchange. So we also have got information challenges. The communicative key expertise translation facilitates mutual understanding, and holistic dialogues are meant to comprise more than two stakeholders. Ontologies are fundamental for level comprehensive, holistic, and cooperative translation. In the Horizon 2020 project, OntoTrans, ontologizing, based on the ontology EMMO, is path-breaking for boosting translation. The translation challenges following a human-centric way are known from language and linguistics, because humans have the habit to talk to each other and to transfer information, and finally, they might need to reach targets. And this is done in natural language following a certain sequence of steps, following the Peircean perception of semiotic processes. A typical approach would be dynamically applying triads of steps, beginning with an abductive reasoning on a level of firstness. In the initial state, the communication will be inter-semiotic, and if a chance is to be identified or a challenge is expressed, then typically the persons communicating take their best shot. In the second step, which is then the deductive reasoning, they try to find a law to be applied. And this is on an interlingual level, and a conclusion is quasi guaranteed in a way that they have an idea of how to approach innovation, to make it a shared innovation and develop a certain habit of assessing innovation. Then inductive reasoning on a thirdness level, intralingual, is used to move from the specific to the general. From the specific to the general, that means again that we, when having reached a certain conclusion on a thirdness level, we can go back to the firstness level and get consecutive triads. So when we want to make translation a white box, then our approach would be to communicate the way to both or all of the participants and conclude step by step. That means the dialogue partners, that may be clearly more than two persons, they are basically considered here as roles, teams communicating. They may opt for a convention-based semiosis or translation process, for instance, following the ISO 17100 that expresses requirements for translation services, or in my community, the German norm DIN 6701, which is related to adhesive bonding of railway vehicles and parts, and which shows a checklist of requirements with checkboxes, which are then followed in order to guide the translation process. Finally, the EMMC Translators Guide presents 6 steps to be followed for governing and guiding the communication between the translator and their customer or client. So we will have to expect stepwise conclusion among the dialogue partners after each step of abductive, deductive, or inductive reasoning, after each triad, ADI. In the semiotical point of view, the interpretant is developing dynamically, and in materials modeling, we will have a conclusion after each of the 6 steps of translation. In OntoTrans, to achieve fair translation as a base for fair innovation, the OntoTranslator uses ontologization, which is a second semiotic process, and this requires a certain expertise of such an OntoTranslator. The OntoTranslator then is given tools which are semantic technologies, for instance, based on ontologies. And if typically the challenge for innovation in manufacturing is to replace this yellow object by a new green object, that means we have a two-way process. An industry need is answered by a specific solution. Then OntoTranslation, which is fair for the involved managers, opens a 3-step process, starting from expressing the need, followed by the ontologization, and finally communicating the specific solution in a way that facilitates closing the cycle and to use the cycle again, express a further or more specific industry need, and the acquired knowledge can be reused. What is characteristic for fair translation and innovation is that the OntoTranslator and the manager, the two humans, or the humans who occupy these roles, they share concepts. The dialogue partners, when following this convention-based ontologization, may typically sketch their conceptualization, and for the innovation process and the manufacturing process, they have got some input objects and output objects. The specific solution requires that one of the output objects is new, and in between there's a process chain divided in steps and objects interacting with the input objects during the process. So the concepts are basically represented by boxes and are kind of fundamental. Inside of the organization of the manufacturer, then there will be a project framework, and the dialogue between manager and translator follows dialogues which have been performed inside of the enterprise or between the enterprise and the customers. And the innovation relevant options for changes are elaborated on the level between level 2, the business process, and the level 5 and the task. And here, basically, the innovation case related processes are located. So fair translation and innovation would mean that OntoTranslator and manager cooperatively find a first solution when this loop is run once. The ontology makes sure, safeguards, that the manufacturer as an organization is included, basically invisibly, and that the end user also is included. So the communication is basically between project managers and the translators on this side. So including the concepts in the ontology greatly helps not to lose the global background and also not to lose the newly gained information, data, which was won, for instance, after materials modeling process, after the sixth step of translation in materials modeling. The result, the output, can be reused because they provide additional new data, which then are available within the client, and the R&D manager holds in his hands or her hands the new results and the ontologized old or already known concepts at the beginning of the project. In the subsequent steps, then heading over to ontology, which will then be presented by Emanuele, the OntoTranslator team formalizes the conceptualization that was elaborated by manager and translator. And following this dialogue, the OntoTranslator team integrates objects and processes of the innovation case with a fair framework provided by an ontology. They realize the perspective used by the manager, greatly profiting from guidance by a multi-perspective ontology, the EMO, for instance, and the team links the conceptualization with an exemplarily perspective specific ontology branch in a way that concepts are related to appropriate ontological classes, the interactions are related to ontological relations, and individuals are related to ontological entities or things. And with this perspective of mine, I would like to hand over to Emanuele.
Okay. I'm going to talk you about technical materials manufacturing innovation challenges from the perspective of ontologization. So what we did in OntoTrans. So how do we understand materials, but more important, how do we understand each other? So we started to try to solve this problem in 2017 when we decided to go for the ontological way to address this type of issue by starting to develop the EMMC ontology, which is based on the perspective of people working in applied sciences, and especially in the material field. So we started to use an approach that has been used in the ancient days by Aristotle, for example, that introduced the concept of metaphysics, so dealing with existence and properties. But then we landed on a more manageable way to deal with ontologies, which is being introduced in the 90s with the semantic web technologies that are aiming to make data internet machine readable. So the fundamental idea behind an ontology is to provide a description of the world that is also understandable by the machine. And so an ontology is essentially a representation of of our conceptualization of the world. So we express using a set of axioms the relation that stands between the individuals, or the instances of that we recognize in the world, and provide classes and relations to connect them. But more important is the fact that this conceptualization, which is understandable by the humans, at least in this case, using a picture, but this can be done also using other sort of elucidation, so text or diagrams, and so on. So this type of conceptualization can be represented in an ASCII format, for example, in this case, with Tartar syntax that is expressing this conceptualization, making this machine readable. So the importance of ontologies, in our opinion, can be expressed by this equation. So physics is related to math, as industry may be related to ontologies. So the idea is that math and ontology can be languages for two different sectors, and the ontology can play the role that math played with physics, which is to push physics to a higher level, like happened in the past when Galileo first, and Newton, and then Maxwell then started to use math to express physics concepts. So giving their theory the possibility to predict what was going to happen. So an ontology shares with mathematics some characteristics. For example, it's a universal language, meaning that transcends linguistic differences. It is hard to learn, for sure, because it requires training. It is able to perform logical reasoning, so it can infer new knowledge from the existing one. It provides models of the world, so we can play with the abstraction instead of material things. And when it works, it can be hidden. So the idea is that ontology can be used as a underlying tools or methodologies to make complex things easier, so they can hide behind the user interface layer. So math has been the key for the highest achievement in physics. So ontologies can be the key for quantum leap in industry, because in this, using ontologies, we can enhance digitalization, push for knowledge sharing, and move from industry 4.0 to 5.0. In fact, ontologies uses concepts which are things that stay in the human mind to represent the things that we see in the world. Just like physics uses quantities to model the world, but physics then is limited to quantities. An ontology is not limited to quantities, but is limited only to our conceptualization domain. So, machine understand the logical language of ontologies, for example, first-order logic or our language, and can be already used to document data, for example, with simple ontologies like DEC terms or DCAT, which is modern ontology, are a set of scattered relation and taxonomy. Can infer new knowledge, so with listeners, or can support AI in ontology-assisted AI. So one of the important things that we have to consider when dealing with ontologies is the fact that in order to jump from the world to the world of ontologies, we need the conceptualization. So we need to go through the different ways in which we look at the world and isolate the things and the relation that we see in the world. So several conceptualization may exist for the same thing, so that almost each human being is going to provide a different definition for a single term. While in physics, this is not the case, because quantities are usually well defined with the measurement practices. That's not the case with more general concept. So what we have to, what we did in OntoTrans, what we learned in OntoTrans, and we put in the MMO is the fact that we have to deal with pluralism. Pluralism means that comes from pluralis, that means belonging to more than one or belonging to many, and is defined as pluralism is approach that embraces a diversity of view, of stance, rather than a single approach or methodology. And there are many different ways of pluralism, but I don't want to go too much into that. Let's make an example of pluralism in industry. For example, let's take ISO 9000 or ISO 40040, which provides a very nice definition that seems to provide light upon darkness. But if you want to use ISO 9000 or ISO 40040, you will find that there are some inconsistencies. For example, the product in 9000 is here on the left is a product or or a service. And here, no, sorry, okay, it's in the ISO 9000 the product is a good, but in ISO 14014 is any good of service. So if you look here, you can see the different taxonomies that comes from the two definitions. So product is the output of a process, and the service is also the output of a process, but it's not a product. So it is tangible. While in this other ISO, you will see that the product is actually a good or a service. So it can be tangible or intangible. So how can we deal with that? This is only an example, because if you go through chemistry, you will see also that if you want to conceptualize chemistry, you will have some similar sort of problems. If you look at the molecule with the perspective of a chemist, then we will find useful to consider a molecule made of atom. And so you will end up with something like this, according to the IUPAC. Or if you are more physics oriented, then maybe you can consider that this type of atom partitioning makes no sense, because a molecule is simply nuclei and electrons that are glued together by some forces, and that an atom is simply a subclass of a molecule. So what type of conceptualization we should use? So how can we deal with that? So the idea is that we have to not to impose from the top an interpretation, but we have on the contrary, we have to create an ontology that hosts this different type of approaches. So instead of the rule the more approach, we would like to use a pluralistic approach to find similarities and differences between different conceptualization. So pluralism can be expressed like that. So you can have underlying grid which is agnostic, upon which you can place or define specific vocabularies that can be incompatible or can have different overlap. And this is providing a human-centric approach that can lead to Industry 5.0, which is, stress the fact that we have to go towards a human-centric approach. And so ontology development, in our opinion, should embrace pluralism, which is in the form of allowing multiple representation of the same real-world object. And this is truly a gateway for the human-to-machine and machine-to-human interaction. So what is a product in practically speaking? So it is a process or an object. Well, it is both. It depends on the type of conceptualization that you want to choose. So what we decided to do is to focus on concepts and not on names. So, for example, we can provide an underlying topological characterization of things in which we represent product and processes and their relation using overlapping or contact and so on. So we will use semiotics to approach knowledge representation and pluralism. So in this way, we will be able to implement practically pluralism. Methodology, so it will be used to fill, not to substitute, the sloppiness of existing vocabulary. So it will provide a deep level of detail for existing standards, so that we can find something that is beyond every interpretation, every pluralistic interpretation, and then we can host the many different ways in which things can be expressed. So the idea is that the MMO is going to provide a top-level meta-topological agnosticism. With meta-topology, we mean parts and connectivity. So. And then we can build perspectives that represent the world in the many different ways in which someone intend it. And then we can build discipline that may use of these different perspectives to define themselves. For example, a perspective can see the world represented by objects and processes. Another one can represent things as fields or matter, and so on. Or parts and whole, for example. So the discipline will be built according to merging different perspectives, according to the willingness of each domain ontology creator. So we will in the MMO we will live with perspectives. So there are many ways in which you can express the same thing. and the basic concept behind every perspective are essentially physicalistic ones. So we look at the world as a physicist. So we have different perspectives, like the holistic perspective, in which things are considered distinguished in whole and parts. We have the physicalistic perspective, in which we have the matter and field that are the two main important categories that represent things. Or we have the reductionistic, in which we create a hierarchy of granularity between things, or the perceptual, in which we represent things according to the mechanism, the channel of perception that we use to be aware of them. And so that, for example, if you take a book, this can be represented in many different ways. For example, on a physicalistic approach is a solid aggregate of organic and inorganic molecule. In a reductionistic perspective is a hierarchy of pages, paper, fiber, and so on. Is in the symbolic perspective is made of chapters, paragraph, words, symbols. In the semiotics is a sign that stands, for example, for the life of a person, if it is a biography. In the holistic perspective is a whole and also an object. So in this way we can represent things in many different ways, so that you can choose your own way, but then you can extend what you want to say about your things according to other perspectives. So, for example, in the modern perspectives, then we merge two perspectives, like the holistic and the perceptual, in which so that we can introduce the concept of model, which is a mathematical object that stands, so it's a sign for something else. So the same can be done with quantities. So we can also represent quantities using a syntactic description of the properties, and then connect them to a material using this relation. And also we can use this type of approach to document data, for example, to extract the actual content of the data, or to attach some properties to the document using semiosis. So merging, the reductionistic approach and the semiotic approach, or also to map syntactically and semantically the data. And for example, in the SIF ontology, we use this approach in which we look at the things according to the syntax. So a value is an expression of a syntax, is an expression of a data type, is an expression of a semantic meaning, and it is part of the semiotic process and stands for a material. So in this way, we can provide all the aspect of a thing. So this approach, as you can see, is extremely multidisciplinary, and what we experience in OntoTrans is the difficulty to grasp the complexity of the scenario and competencies and technologies. So what we're going to do what we are doing as ontology developers is trying to put together these people. So philosophers that unfortunately are driven by curiosity and have difficulty to view their application. Ontologies that are logics, so strongly committed to rigid deterministic systems. Computer scientists that would happily drop logical complexity to a minimum to make the things work, to make the machine run. Applied scientists that usually don't believe in ontology because they have already mathematics. And engineers, they would love ontologies, but they don't want to abandon their standards towards a new one. So what we need now, it's required multidisciplinarity, and ontologies can be the catalyst to do so. So what we suggest is that we should more and more push for a strong multidisciplinary approach in our innovation, and propose ontologies as a way to push for such a multidisciplinary action. And because extraction of knowledge from each single discipline is more and more difficult, and innovation comes when you jump out of your well and start to see how to do things in a combined way. So the importance of semantic approach to knowledge, in our opinion, is that provides a new language, digital and machine friendly, that push for the transition toward Industry 5.0, and really can be the driver for innovation. So this initiative is not only related to OntoTrans. OntoTrans give an important push for this development in the EMMO, but also is shared with other important projects of Horizon 2020. And I would like to thank all the people that are working with together with me in the development of the EMMO.
Thanks for the presentation, and I'd like to also encourage our participants to post the questions in the Q&A. We will have one more presentation to come. That will be the presentation by Jesper Friis, who's going to then conclude also on the on this OntoTrans contribution. So over to you, Jesper.
Okay, so I will speak about the last perspective here, how do we communicate and share materials data. Yeah. So first, I just want to start with an example. We had this, you probably heard about this Mars climate orbiter that during when you try to intercept go around Mars, the thruster was sending its the thruster control was sending its input, communicating using pound for seconds, while the trajectory control was expecting SI units. So what happened was that it lost control and was burning up in the atmosphere of Mars. So even though the numbers that were sent there was interpreted correctly, there was no interoperability because the meaning of the numbers was misunderstood. And that is very important, that we not only are able to communicate just the numbers, but also really make sure that we are understanding the message correctly. So when people speak and communicate, it is usually the responsibility of the sender to ensure that the message is understood. But for communication between machines, it's typically the receiver that has the responsibility to understand the message. But when we want to go to semantic interoperability, we have to change this view and also put more responsibility on the sender. So the one sending the message has to communicate semantically, use a common reference framework, an ontology. And of course, the receiver has to understand this language. But this, using such a common reference language, we are then able to send messages. And for instance, include the units when we are sending the messages from the thruster to the navigation system. So in order to communicate or simplify communication of materials data, we should use semantic interoperability. And as Emanuele mentioned, when ontologies work fine, we can hide the complexity behind all these interoperability operations. That's the same here. It allows us to communicate unambiguously information between different systems. So we avoid this misunderstanding I started with. And of course, improve fairness, reusability, scalability, accessibility, and so on, interoperability between the systems. Here's an example from a project. We have a knowledge base or triple store containing a lot of information, and this image here symbolizes individuals. In a knowledge graph, we have such these individuals. We have a lot of relations between them. So it actually form a spider net, such a graph, and it gives us semantic context. So when we are looking at this instrument here, We can ask who was operating it, what was actually observed in a given experiment, how was this image analyzed, what was it, what kind of structure was it that we were analyzing, what parts of this software was in use. Here, this structure here has it been modeled by thermodynamics? How was it modeled using DFT? Who was the person doing the DFT? What computer systems, and so on? All these contexts can be put in, and that is what we have in a knowledge graph. The ontology plays the role of a schema for such a knowledge graph and give it a system. Give a more formal description of it. In OntoTrans, we have it's based on a central triple store, and then we try to have a set of internal apps and other internal exploratory systems that are communicated both with each other but also with a lot of external data resources. And what we try to do in OntoTrans is to make an interface layer such that this heterogeneous set of data resources can be accessed in an easy and homogeneous way within OntoTrans. It also is also important for the project that we try to make the onboarding a new data resources as simple as possible by, for instance, reducing hard dependencies and also by separation of concerns. So one person that is good, the responsibility for onboarding can be divided into tasks. For instance, implementing the interface, that can be a task for a software engineer. Mapping to ontology, that might be a task for another person, and these tasks can be well separated. So integrating an external data resource, there can be different types of resources, documents or files that can be downloaded. You might access a database, or there might even be complete APIs providing the information we want. But in common is that we need to have a step where we retrieve a schema for the resource. We can then create an internal data model representing the data resource we want to connect to. That data model can be published and shared between other users later on of the data. And to make it fully semantically described, we can also map this data model to ontological concepts. To look a little more into what we mean with a data model. So we have an entity which is a kind of one entity in the data model that is self-contained. Such an entity, they have a URI that identifies it uniquely, containing a namespace, a version, and a name. So if you are making a change, you increase the version number. Okay, this is a technicality. It's a part of the data model itself is an instance of a metadata model, essentially. But the more important is that it has a human description, and then it defines a set of dimensions that each have a name and a description. And this dimension here are then used for the properties. For instance, if you have a vector of different lengths, so the property would have a name, a type, a shape, which is connected to the dimensions, units, and a description. And more difficult, at least in OntoTrans, the data model we're working with are so simple as this one here shown. But they are sufficiently semantically that you can generate code from it, and it's possible actually to make these connections that I showed before. We can use the system also to discover new resources. So if you have a data catalog that knows possible external data resources, have a entry for each resource. It's possible using, for instance, the ontological mapping to actually search also ontological for what kind of data resources we have that contains these kind of properties that we are interested in. And we can search for the actual data sets the same way, also using the data catalog that knows about not only the data resource, but actually also the data that exists there. An example, just I want to end with that, is that we have a database with some molecule structures. Then we have a person, Alice. She's very good in calculating molecular energies from these and can express this in a data model we call here the molecule data model. Another person, maybe independent, needs essentially the same information that Alice has calculated, but he is representing what his input in using another data model, probably because they have been working independently. And what he calculates is simply reaction energies. What those energies can then be used by a third person that actually has a concrete chemical reaction. For instance, this dehydrogenation of methane, has to be methane. Okay, and so the way to go ahead is that for the first step, can happen really automatically, is that you have the molecule data model. It contains a set of properties. It's possible to map all or just the properties you need to concepts in the ontology. The same for the substance data model. It has also some properties that are mapped to the ontology. And then it's via these mappings here, it's possible to take the instance of the molecule data model, automatically generate instances of the substance data model that Alice was needing for her calculation. She can then do this, calculate the energies of the reaction energies. She's probably calculating. Yes, she's calculating reaction energies, and these can then be used for the third creating an instance of a reaction data model that contains for us giving chemical reaction. That this part here would in OntoTrans probably be implemented using a transformation step that has been formalized, that is more predefined and not on the fly generated as the first step here. But still, it can happen. So when it's defined and it can be stored in a repository, and whenever we get back to a case, maybe another chemical reaction, you can reuse it and instantiate new chemical reaction instances that are the last serial participant was needing. So with that example, I want to thank you very much and open for the questions.
Thank you very much, Jesper, and thanks also Michelle and Emanuele. So all of the talks are open for questions, and please join the stage as well, everyone. So there is one question here on, it says ontology could be the tool to express reasoning to generate industrial innovation, question mark.
Yeah, I think that the question is not correct. So reasoning cannot be expressed. So reasoning is a process of obtaining new knowledge from the previous one. So reasoning is something that widens your understanding of things according to a predefined schema. So predefined ontological actions. This maybe is not directly related to industrial innovation, so it's not this outcome of the reasoner, the innovation, but this provides a cleaning of the concept that you want to express, and then facilitates innovation. So facilitates the way in which you put together knowledge and in which you represent knowledge to each other and represent knowledge that can be interpreted by the machine. So if I interpret correctly the question, I think that this is the only answer I can give.
Thank you. And any other comments from that? I mean, if not, I would maybe have some, or maybe comments, or ask you for some more elaboration on a few things that I was wondering. The one thing was that was mentioned, I think, by all of you, really, is the interaction between people, and the bottlenecks also that were quite nicely expressed, I think, in with some of the pictures that you had in your slides, Emanuele, of the different people having their own views on things, and that can hinder the communication and the conceptualization, the use of ontologies, and so on. What's been the experience in the OntoTrans project now with facing that challenge of actually having all of these people together and doing the work? What has been, your experience in overcoming the bottlenecks in the specific case of the OntoTrans project?
If I may take that very shortly, I would say talking and discussing. Typically, as we do, we have a translator related to user case. They have an intensive discussion, and then we have a second level of discussion that basically both of them, they explain to the team working with the ontologization. So there's several filters, and jointly then the expressions of the challenges, they develop further in a way that more and more people can understand it. And I think somehow guiding the communication by these steps, and in between the conclusions that each team makes and then gives back a response, the iterative approach, I think this is characteristic for human communication, and that works in OntoTrans nicely, but it also turns out that it's time consuming, and typically I still make notes, writing on a piece of paper, and afterwards I have problems to find all of the information. So I'm happy if we can ontologize everything.
Yeah, thank you. Any other comments on that, or experiences of working in OntoTrans?
I share very much the experience by Michael. It's very rewarding, but we spend a lot of time communicating, trying to understand the perspective of learning the language of the industrial case. That takes a lot of time, and you have to do that before you're able to ontologize.
Yeah. Now, of course, mixed in. I mean, Emanuele, feel free to comment as well.
Yeah, if I may, that's also what I wanted to stress in the presentation, and what I want to stress also in the EMMO development, with my contribution to the EMMO development, the fact that interpretation is maybe together with the logical consistency of the theory, is the most important aspect of ontology, which is usually, sometimes ignored. But if you have if you want to be successful in providing this approach to industry, we need, of course, to embrace pluralism and to make the people aware of how to express their concept in this framework. So the MMO is still working on his internal mechanism and this logical structure. So it's lacking documentation up to now. But this is an important point that we have to deal with. It's impossible to do without finalizing the internal logical structure that we are doing here in OntoTrans. After that, I think that our efforts will be towards a strong documentation and tutorials, examples, in order for this to be understood. And what I've learned in OntoTrans is that an ontology is like a Frankenstein. So it's a patchwork of dead things, which are definition that you find in the PDF, in the stamps, and so on, and that it is not alive. What we need is the lightning, which is the tool. So the tools is an important thing. So we need an ontology, so we need the dead body. We need the lightning spark, which is the tool that makes the ontology work to do something. But then it's not enough, because like a Frankenstein, an ontology can go and kill everybody who meets, something like that. It needs to interact with people in a friendly way. It needs to be understood. So it needs to be loved and to love and be loved. And so that's the part of the interpretation. You have to interpret understand the monster and realize it's not a monster, but it's a powerful thing that can do a lot of good. So I think it's my picture of what
Yes. Just finally, I mean, before we close this, you just mentioned one point here already, I think, which is and which I noted is the technology stack. I mean, it needs, we need to, there is work to be done on the ontology there, but then also Jesper mentioned quite a lot of these things as well, right? The data model tools that go with it, and there's more and more. What's your view on the status of the technology stack and the needs to overcome the tool, the challenges there to make things a bit easier and to bring life, as you say, into this thing?
I think in OntoTrans we are doing quite well when it comes to managing interoperability and finding a good way to onboard data resources and make them semantically available. But there is a lot of tooling that is lacking, and especially reasoning is something that I guess Emanuele can comment on that. But that is there. I think the tools we have are struggling to cope with ontologies we have, and the reasoner we have been using so far, main reasoner Fact++, has not been developed for many years. So I think there's a big, there are also big gaps in the tooling.
Thank you. Emanuele, any comments?
I think we should distinguish between the tools needed to ontology development, which are extremely important, and we are lacking people that are experienced in doing this, and tools that facilitates the development. And I think that the tools that make the ontology alive will be whatever you want. So there can be many different type of tools. There is not one tool to use an ontology. There will be many tools. OntoTrans is one possible tool focused on modeling workflow or knowledge gathering workflow in general. And this is an important application, but there is not only one tool for ontology exploitation. There may be many. So as Jesper said, OntoTrans will cover one we provide one of the pieces of the puzzle of the possible tools, but there may be lots different.
We have some more, maybe we can just fit in a couple more questions here that we have, but also we can then continue maybe in the lounge. But there was the first one, I think, was on stating SIF is an established protocol to store crystallographic information. That was from Hotel Rocione, and is transparently implemented in end-user software. How far are we from having software tools to conceptualize information for other applications? It's a wide-ranging question. It depends on what other applications we're talking about, but I guess that one can emphasize here the work that has been done in certain communities such as crystallography, which is quite outstanding and not the same everywhere.
Exactly, I completely agree with Gerard. So SIF provided us with an already not ontology really, but ontology, translatable dictionary. So so that's why. So how far we are depends how good the community of the particular discipline to which the application refers to, how good this community have been to formalize univocally the state of things in a conceptualization. So that's it. The main problem in developing an ontology is exactly that. It's we usually stuck against the lack of good understanding from the discipline. That's why we need pluralism, because we don't want to fight the fact that there are many different understanding of things. We want to be agnostic as much as possible in the methodology, and to be open to provide a framework that will allow the coexisting of these different views. But this takes time.
There's also then finally, is there room for improvement in tools for visualizations of ontologies?
Definitely.
Yeah.
I think there exist many tools already, but they are not very user friendly or require some experience to visualize those parts you are interested in.
Thank you very much for again to Michel, to Jesper, to Emanuele for the great presentations, and thanks for your participation.
Thanks to all of you. Bye-bye.
Bye-bye.
Bye.